Okay, first things first. If you are absent today, here is your warm-up problem. I'll let you pause the video so you can get it done, and then you can play again to watch the lesson. Okay? Alright, today we are talking about investigating transformations on quadratic functions. There's a couple things that I want you to know about. Okay? So, first thing I want you to do is fill in the table right up here. Fill it in. Complete the table to make an accurate graph. So if x is -4, what's -4 squared? What's -4 times -4? 16, right? Not negative, but 16. Okay? What is -3 times -3? 9. -2 times -2? -1 times -1? 0 times 0? 1 squared. 2 times 2? 3 squared. 4 times 4. Anybody catch what I just did there? What I want you to know that squared means? Something times itself, right? Because for this one I said what's 2 times 2 and then what's 3 squared. Right? Do you realize those mean the same thing? Good. I've noticed that sometimes vocabulary is an issue for us, so I'm trying to make sure we understand the words. Is that a deal? Okay. So let's plot those over here. Let's plot them. So -4, +16. -3, 9, which is right here. When x is -2, y is 4. -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. Can I connect these points? Are these points discrete or continuous? How do you know they're continuous? We have an equation, right? Okay, everybody okay with that? Now, is the only time you can get continuous when you have an equation? No, of course not. Okay? But that's a good start, right? This is a horrible parabola. I'm sorry. It's a little better. Okay? So let's pretend you go home tonight. I mean, we don't have to pretend that most of you are going to go home tonight. But let's pretend you go home tonight and you have like 4 pages of homework that you have to graph stuff on. You don't want to get a 0 for your homework, most of you, right? So, but you have a computer, right? I know this is an iPad, but we're going to pretend like it's a computer. Okay? So I'm going to go up here that you can't see to my address bar thinger, desmos.com. It looks like this. Why is it doing that? Just pretend you can see it. This is the only button you need to really see, right, is this red one right here. Can you see what it says? Launch calculator. Now you can sign in. There's a create an account button up here, and I may end up having you do that eventually. But if we launch the calculator, it will load, and then you will see. Seriously? You can't even see it at all. Kind of? Kind of, sort of? If I turned my Apple TV on, you could see it, but you couldn't see it on the screen, on the video. Okay? So let's pretend we can see it, like that. You see this place right up over here? If I put in y equals x, where'd the x go? X squared. Can you see this? Can you see that graph? It graphed it for you. And then if I press enter, like it'll give me a new line to enter a new function. Okay? Everybody okay with that? This one's still here, it's just not as thick, so it's hard to see right now on the screen. Sorry about that. I thought you would be able to see it a little bit easier. But it's because I'm trying to show you that it's breaking, right? Or not working. Okay? Desmos.com is an online calculator. It's free. There is an iPad app. So if you have an iPad and want to get it, it's free. I just wanted you to know about it just in case. Okay? But we have our calculators. We all got our calculators as we came in, right? Just like we always do. Get up and get them. Okay, so here's the deal, guys, about transformations. Okay? We've already done transformations at least 3 times this year. Okay? We did it at the very beginning of the year when we talked about parent functions in general. We talked about some transformation qualities. Then we did it with linear functions. Then we did it with absolute value functions. Okay? So some of these rules, hopefully you remember. It's not like, I mean, you are so smart, but some of these rules you're actually remembering and not just knowing out of your head. Okay? Which is fine. That's a good thing. Right? So here's the parent function, y equals x squared. Here's the function we want to graph, that we want to compare to the parent function. Okay? I'm trying to get my calculator to work and it's not liking me right now. Document, save, no. Okay. So in my calculator, I want to put in y equals x squared. Right? Now, before I put in my second one, which I'm going to do by hitting tab to get that line down here to come back up, I want to make some sort of guess in my head about what's going to happen. Or even out loud. What do I think is going to happen when I change it to negative x squared? Okay. So, negative x squared. Did it do what you thought it would? Okay. So let's transfer that graph here. And then what can you conclude? Guys, I want this in your words. I'll make sure we know the right math words later, but I want this in your words. What are your words? What can we conclude? If, what happens? If we have a negative sign, then what? The graph flips. So, number one, I need you to make sure that you understand that these are not really the correct math words. They're the right regular language, like English, right? We have a negative, and it flips. Yes? Any guesses at the real math language? If we have a negative multiplier, right? If we have a negative multiplier, the graph reflects. Okay, I know somebody said that a minute ago and that was fine. I was just making sure to get what most of you guys were saying. Okay, now don't worry, I don't want you to go ahead and write that. There's a place for us to write the correct math language here in just a minute. That's why I want to get your language here, and then I will make sure that our vocabulary is all the same. Okay, so what happens here? X squared, and then we have x squared plus 4. Make a prediction, either in your head or out loud. What do you think is going to happen? Now, I don't think anybody in here will have a problem with this, but does anybody in here have a problem if I hit tab and just put this in at f of 3? Or F3? Because if I do, there's going to be 3 graphs on the sheet. I'm not going to need this one because that's what I just used. Anybody have a problem with that, or are you okay? Okay, so x squared plus 4. Did you make a prediction? Did it do what you thought? Okay, so my sketch is like that. What can you conclude? If a number is being added, is that what you said? If a number is being added, where is it being added? To the x squared term? Does that matter? No? Yes? Maybe? Okay. We may come back to this one then. Okay. So if a number is being added, then what? It moves up. Okay. So what do you think is going to happen on 3? You think it's going to go down? X squared minus 4? Did it? So here's the problem. Some people think that it got bigger. Did it get bigger compared to the parent? Here's the parent right here. This looks bigger. You can just see more of it. Very good. Okay? So it did move down 4. So what can you conclude? If a number is being subtracted, then it moves down. Is that what you said? Okay. Any questions so far? Okay. What about 4? What's your prediction? It's going to move to the right. Is that what you said? Uh-oh. Did I do something wrong on the calculator? That's what I put in. That's the same, right? Remember back to when we did absolute value functions? What happened when the number was in the absolute value sign? How did it move compared to the parent function? Opposite of what we thought. Do you remember that? Opposite of what we thought? Okay, so it moved over here. So what can you conclude? If a number, if a number is being added, guys, we already said that. If a number is being added, it should move up. This number is being added, why didn't it move up? Because we're what? We're inside the parentheses. Where are we here? Outside. Okay? Now, it's not so much the parentheses that are important, but the squared, right? This is outside of the number being squared. Do you see that this one right here is inside the number being squared? So do you see why I asked you about directional words earlier? Is it enough just to say if a number is being added? What should that say? outside. If a number is being added outside, we could say outside the square. That's good. Okay? Does that make more sense? Doesn't make sense to anyone. Okay. So then what should we say here on number 4? Inside? Then what? It moves left. So if a number is being added, it moves left. Okay. So what's your prediction for 5? Move to the right. Let's check it out. Do you guys notice that when you open a parenthesis with that button right there, open a parenthesis, that it adds a close also? Do you know that? Now it's not being nice to me. There. All I did was open one. Can you see the little imaginary close one? It's not solid because I haven't moved my right arrow. X minus 4 squared. So where'd it go? To the right. So what can we conclude? If a number is being subtracted inside the square, questions so far? Okay, so what about 6? What's a prediction? It gets bigger. It gets smaller. I heard both of those. Okay, let's go check it out. Let's see, tab 2x squared. Remember, the one I'm currently on is the one that's going to be the darkest, right? What happened? Okay, I know I have a lot of graphs on here, but this one right here, that's my parent function. So what happened to it? What do you mean it got smaller? Skinnier? So if numbers are on the outside, is this number on the outside or the inside? It's on the outside, right? It's not being squared. So it's on the outside. Historically, what's happening to things if it's on the outside? It's moving up or down, right? What kind of change is that? Go grab me the balloon. Isn't that a vertical change? If I'm moving it up or down, isn't that a vertical change? So, even though it looks like a compression, it's not. Okay? Can you see this black balloon? I can't make it go any further. Okay? So, do you kind of see that this area right down here is like a parabola? Ish? Not exactly, but ish. So, there's 2 ways I can make this narrower. I can mash it in from the side. Do you see how it got narrower when I mashed it in on the side? What's the other way I can make it narrower? If I hold it at the bottom and hold it at the top and stretch it. Right? So it depends on if I'm talking about a horizontal change that gets this way, or if I'm talking about a vertical change that's this way. What way am I talking about here? If the multiplier is on the outside, I'm talking about a vertical change, aren't I? So what kind of change really happened here? It's a stretch, isn't it? Okay? It's because it went from there to here. So what can we conclude? Let's put it in your words first, and like I said in a minute, we'll put it in my words. I just wanted you to see that when we were talking about it. If we have a multiplier, what kind of multiplier is it? Greater than 1? Then what? It stretches. Now, we can say that because this is on the outside. So if we have a multiplier outside, okay, then it stretches. So what happens here? What do you think is going to happen? It gets bigger? Fatter? That's not really a nice word. So tab 0.5 x squared wider, fatter, any of those will work. Here, this one right here is our parent function. Okay? Bye, see ya. Okay? So it got wider than the parent function. So what can we conclude? If we have a multiplier outside, I always like it when outside is actually outside the box. That makes me laugh. At church last night, I went and did this on my head. I itched my head like this, right as our speaker was saying. Sometimes we just make God scratch our head, or scratch his head. And I'm like this. I'm like, whoa, that was weird. So, and the girl sitting beside me, my friend Amanda, she was like, ugh. It was funny. So if we have a multiplier outside less than 1, and what? I'm not ready for that yet. Okay. I'm not ready for the comma yet. To finish my little part of my sentence. Oh, why does it have to be bigger than 0? What happens if it's less than 0? What happens if it's less than 0? It flips over, doesn't it? We don't want that. We just want it to get wider. So it has to be less than 1 and greater than 0. So if we have a multiplier outside less than 1 and greater than 0, it what? It gets wider? Or fatter if we're being judgmental, right? Fatter. Okay? So, here's what we've got to do. We've got to fill in this chart right here with the effect on the parent function. How does it change compared to the parent function? And the domain and range. Okay? And the domain and range. So, this is where we've got to build our vocabulary, or actually remember our vocabulary. Fair enough? Okay? So, what did we say the negative does? What we said in our own words was that the graph flips. I actually spelled it wrong. You guys didn't even say. The graph flips? Really? How about then? Oh, okay. Okay, so you saw it. You just wanted me to look dumb because I can't spell words right. Thank you. Okay. It's okay. It's okay. So, what are our math words here that we want? Our vocabulary. reflects over what? X-axis. Very good. And I also want you to know this. Across. It can reflect over the x-axis or across the x-axis. I've seen it both ways before. Okay? So what it looked like was that, right? That's what it looked like. So what is the domain of this new function? Do you remember why we're using the D? Oh, domain. It's the first letter. Yay for us. What's the domain? What in general, what is domain? It's our x's, right? So how far left and how far right does it go? How far left does this go? Forever. How far right does this go? So, all real numbers. Can I use that symbol? If I remember what it means. Absolutely. Okay? So what about my range? How far down does it go and how far up does it go? How far down does this go? All the way. How far up does it go? To 0. So it's everything less than 0. How do we write that? Y less than or equal to, how about if I write the right one? Is that okay with you guys? Less than or equal to 0. Oh, goodness is right. This is exciting. Okay? So what about B? How did that move? What'd you say? It moves up the x-axis. I need to make sure you understand both of kinds of vocabulary that can be used here. So we're going to use one on B and one on C. Please understand you can use either one. Okay? I just want you to make sure to know both of them. We can say that this is a vertical shift up 4. And if we want to be really, really good, we can say up 4 units. What's the most important part of this word right here? The F, right? Make sure you write your F. Don't forget it. And this graph looked like this. Right? It shifted up 4. How does that affect its domain? How does that affect its x values? Say it again. How far to the left does it go? How far to the right does it go? So what's its domain? All real numbers. What about its range? Y is greater than or equal to 4, right? Because how far down does it go? To 4. And how far up does it go? All the way. Questions so far? Okay. So, once again, the vocabulary I'm going to use on C is a little different. They mean the same thing. I want you to be familiar with both of them. Fair enough? Because what would I write here if I was using the same vocabulary? Vertical shift down 4 units, right? I also want you to know this. Oh, great. Thank you. I don't know what's the deal with my spelling today. I feel like an actual math teacher that sometimes can't spell. So that's what this one looks like, right? So what is its domain? How do you know that? Because you're a genius? Okay, that's a good reason, but how else? How far to the left and how far to the right? Okay. What about the range? How far down does it go? -4. How far up does it go? So it's everything greater than or equal to -4. Very good. That's a really good question. Is the domain ever going to be anything else? And we'll get there after we talk about G. Fair enough? Okay. So what about D? This one moved left. So which one do we want to use? I want to use one vocabulary for this one and one for this one. Translates. Okay. Translate. TES. Translates. Left. 4 units. Domain. Because how far left does it go? How far right? Okay, what about range? I heard 4, I heard 0, I heard -4. The good news is that one of those is right. How far down does it go? On the axis, how far down does it go? To 0. How far up does it go? All the way. So it's y is greater than or equal to 0. I'm not talking about shifting over left and right. That's domain. Remember range, I'm only talking about up and down. So how far down did it go? It went all the way to the x-axis that has a value of 0. And it went all the way up. Is that better? Are you lying? A little bit? Okay. What about E? Horizontal. Horizontal shift. Right 4. Questions? Then tell me the domain. Okay, what's the range? What'd you say? 0. Very good. So what about F? What happened to F? I need to get the balloon out again. It's a vertical stretch. By a factor of what? Very good. So it went like really steep, right? Instead of like here, it's steeper. So what's my domain? All real numbers. What's my range? Perfect. And the last one? Vertical compression by a factor of 1/2 or 0.5. Well, we'll say 1/2 because that's what was written. Okay? So if this was the regular one right here, it went fatter, wider. Okay? What's my domain? All real. What's my range? Greater than or equal to 0. So let me answer another question that some of you are thinking first before I answer Haley's question. Is that okay? Some of you are thinking like this. Why are we doing this? Right? You think that like every day in my class. what does this even have to do with? Why are we doing this? Well, here's the deal about quadratics, guys. Parabolas. Parabolas are a lot more places than you think. Does anybody have a satellite dish at their house? Like you have satellite TV? Okay, Kelsey, when you go home tonight, I want you to rip the dish off of your house and bring it to school tomorrow. Is that okay? No? Come on. No? Okay. Let's pretend then. Okay? Let's pretend we had Kelsey's satellite dish. It's a circle, isn't it? And we cut it in half this way. There's that little thing that comes out, like, you know what I'm talking about, that little thing? But let's say we cut it in half this way, and then we fold it on its side. So we're looking at it like that. Guess what shape this is? A parabola. Okay? The thing that comes off the side, this kind of thing that comes like to a spot thing right there, any of these waves that come into the dish, guess where they go? Right there. It doesn't matter where the wave hits in the dish. It's shaped. The parabola shape will send it right to that spot. That's a collection spot. That's what gives you your satellite TV. Okay? Now, I don't want to spoil it by telling you any other places that parabolas are because they can be very exciting. But there's a start for you. Okay? That's why we study quadratics, because they really are more places than you think. Okay? Now, let me give you your homework. Your homework is Haley's question. Her question was what? Ask it again. Is the domain always going to be all real numbers? So what I want you to do, this is the question I want you to answer. Can I think of a way or a parabola that doesn't have a domain of all real numbers? Okay? It's a yes or no question. But the important part is justify your answer. Defend your choice. That's your homework. Write it right down here at the bottom. Can you think of a parabola that doesn't have domain of all real numbers? And then defend yourself. Defend your answer. Any questions about that? As its domain. Can you think of a parabola that doesn't have a domain of all real numbers? Okay? So, yes or no. Oh, I do want complete sentences, though. I do want at least one complete sentence as your answer. Fair enough? Okay? I mean, capitalization, punctuation, all that kind of stuff. All right? Any other questions?